I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, I am sharing with you a complete lesson on how do we find area of a regular polygon when apothem is given to us. Now, this is one of the rare videos where I am discussing a complete lesson with you, right? Normally, we only share with you solutions to some problems. So, if you really want to understand the concepts, go through the video till the end. Correct. So, we are talking about finding area of a regular polygon when the apothem is given to us. It's a question which has been asked by many students, and I hope its solution or this particular lesson will help many. Well, in case you want to learn from me, you can always contact me on the email address given. So before we get into the main thing, which is how do we find the regular polygon area given by the formula, which is A equals to half of A times P, where A is the apothem. So from the center, the distance to a side is called apothem. And if the side lengths are S, then perimeter will be, in this case, because it's a pentagon, it will be 5 times S, right? Perimeter. So using perimeter and apothem, we can actually find area of a closed regular polygon. Perfect. So before we get into the solution, let's understand few related terms. So we're talking about polygon. N-gon, we'll say, when we have n dimensions, all are equilateral and equiangular, means all sides are of same length and all angles are congruent. The sides are symmetrically placed about a common center with a constant distance called apothem A from each side. So apothem is actually the shortest distance of each side from the center. Perimeter, you know, is the sum of all the sides. Definitely, if n is the number of sides and s is the length, then perimeter is the product of n and s. If you know perimeter and apothem, then area is half of A times P. Now that's, seems to be now common sense, right? So if I make a triangle joining the center with the two vertices, then we know half base into height is area of this, right? So it is half base into height, correct? Height in this case is A, the apothem. Base in this case is side length S. And then how many triangles do we have? We have the same number of triangles as the number of sides, and therefore the formula makes sense, right? Apothem and perimeter makes sense, correct? Now, many times what happens is that we need to figure out what these angles are, because from the apothem, we can find the side knowing the angle. So for that, we have two angles to look into. One is the interior angle. So interior angle for any polygon is 180 times n minus 2 divided by n. This, is because 3 sides give you a triangle, correct? So n minus 2 will give you the number of triangles, and every triangle, the sum of angles is 180, which means you need to divide by n to get each angle, correct? Now, each exterior angle, well, the sum of exterior angles is always 360, so divide by n to get an exterior angle, perfect. Now, as I said, you might need some trigonometry in apothem related questions, because many times you have to find the side length, right? So in trigonometry, basic concepts are sine is the ratio of opposite to hypotenuse, cosine is adjacent to hypotenuse, tan is opposite to adjacent. I write with the help of SOHCAHTOA sine OH, right? Opposite over hypotenuse, right? So you all remember it with SOHCAHTOA term. Sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. We might sometimes use special triangles to get the exact values, especially when we have angles of 30, 60 or 45 degrees, right? So these triangles relate to the sides of the triangles with those special angles. So if it is 30 degrees triangle, then sine theta, sine of 30, is 1 over 2. And cos of 60 will be square root 3 over 2. Use these triangles to find exact values if required. Perfect. So let's move on to our main question. And the main question here is, we are given a regular pentagon, right? So we need to actually find the area of this regular pentagon, and the area we know is half A times P. So the question here, we have broken down into small parts to understand the process of finding the area, right? So many steps, one of them should be find an exterior angle of a regular pentagon. So as you know, this is the exterior angle, right? So if I extend this, then what angle I get is the exterior angle. So if this is a 5-sided figure, how much is going to be that angle? Well, it is going to be 360 degrees divided by 5, correct? So if I divide 360 by 5, what do I get? Well, it goes 7 times, then 10, 72 degrees. So exterior angle here, we have 72 degrees. Perfect. So for a pentagon, we just found the exterior angle, which basically is 360 divided by the number of sides. And then we need to find the interior angle. So let's find the interior angle also. And clearly, this interior angle is going to be 180 minus 72, right? So this angle will be what? 180 degrees minus 72, correct? So if I do that, taking away 72 from 180 gives me 108. So each angle is 108 degrees. So these are the interior angles. Very clear, right? So see, this is a faster way of finding the interior angle rather than applying the formula, which is 180 times n minus 2 divided by n, correct? I hope you appreciate it, correct? Okay, now, the question here is, find apothem A if perimeter is 100 centimeters, okay? So we are given that the perimeter P is 100 centimeters, okay? So that means the side will be, each side is going to be, let's say S is the side, then each side is going to be 100 divided by 5, and that is 20 centimeters, correct? So we have each side as 20 centimeters. Let me write down here 20 centimeters. Okay. Now the question here is to find apothem A. Now what is apothem? We just discussed apothem is the shortest distance from the center of this regular pentagon, right? So we want to find this distance A, right? Now from the perimeter we know one side, and we want to find apothem, we know the angle also. Well, if I make a triangle, because it's a regular pentagon, well, this triangle is going to be an isosceles triangle. Means these sides will be divided into 2 equal parts, right? So each angle here will be how much? Well, each angle here will be half of 108, right? So 108 divided by 2 is each angle, so which is 54 degrees, correct? So each angle here is 54 degrees. So we know this is 54 degrees, and the side 20 is the total length, so each part is 10, 10, correct? Now you can find apothem A using which ratio? Well, you know the angle, you know the opposite side and the adjacent side, so you know that tan of 54 degrees should be equal to apothem A over 10, correct? And that gives you the value of A as 10 times tan 54. Makes sense? You see how easily we walked it through, right? So A is 10, tan 54. Now once you know apothem, once you know perimeter, find the area of a regular pentagon. Well, just multiply half times A into P, right? And get the answer. You see how easy it is, right? So once again, let's go to this picture once again and see what did we do. So initially what we did was we found the exterior angle, and we found that this exterior angle is basically equal to 360 degrees divided by 5, and that was 72, right? Now from the exterior angle we actually figure out the interior angles. Interior angle will be 180 minus, because it's a linear pair, right? So 180 minus 72, and that gave us 108, right? So this was 108. Now we knew that the perimeter P is equal to, given to us as 100 centimeters, correct? So side length S, if each side is S units, right? In that case, there are 5 sides, right? So 100 divided by 5 gives us 20 centimeters. So each side is 20 centimeters. Perfect. So we then formed the triangles, correct? So the triangle using the center point will give us isosceles triangle. These sides will be equal, and therefore, if I drop apothem, apothem is the shortest distance and is the same distance from the center to any side. So this will divide into 10, 10, right? And the angle is half of it, correct? Half of what? Half of 108, right? So the angle was 54 degrees. And we found that tan of 54 degrees is basically equal to what? Apothem over 10, right? Is that clear? And so from here, we get apothem as 10 times tan of 54. Makes sense. Use calculator to find the value. So basically, we'll do 10 times tan of 54 degrees, right? It gives me 13.76. So I know perimeter P is given to us as 100, and therefore now you can find the area, correct? So area is half of AP, apothem times perimeter. So half of apothem is 13.76 times the perimeter of 100. So let's multiply this by 100 and then divide by 2, half of that, to get answer as 2. So we get, let me redo this, right? 13.76 times 100, right? Divide by 2, right? We get 688, yeah. So now let's do this calculation, dividing 1376 by 2 and then times with 100, either way. So it gives you 688, right? And of course, centimeters square. So do you see how we could actually find the area knowing the perimeter of this particular pentagon, correct? So that's very clear to you, right? Now, you could do similar questions. I could have this. So we already did this one where perimeter is given to us. And now let's say question 2 for you is, let's say the apothem is given to you, right? So at the apothem, let's say apothem is, let's say 4 centimeters. Okay. So if I tell you that the apothem is 4 centimeters, find the area. Right? How will you do it? Well, now you need to find the side length, correct? So let's form the triangle once again. And we just calculated the angles, right? We calculated this is 72, right? And this whole thing is 108, correct? And this is 54, perfect. So we are going to use the tan ratio to find half of the side length, right? So tan of 54 is 4 over half of side length. So I am writing S by 2. Is it clear? So I can write S by 2 as 4 times tan 54. Correct? So S is equals to 8 times tan 54. Makes sense? So side length I have found, correct? So let's use the calculator once again and see what it is. So 8 times tan 54 degrees, 11. So we know one side is 11, right? So once we know a side is 11, all right? So in that case, this whole thing we have found is 11, correct, centimeters. So the perimeter will be 11 into 5, which is 55. Apothem is given to us as 4 centimeters. And therefore, area is half of apothem times perimeter, which is half of 4 times 55, right? So twice 55 is 110 centimeters square. Do you see that? How easy it is to find the area of any polygon for that matter using this concept of multiplying apothem with perimeter and then taking half of it as the area, right? So I hope the concept is absolutely clear. Feel free to write your comments, share your views. If you really want to learn from me, you can contact me on the email address given. Thanks for your valuable time and all the best.